Okay, so in this video we're going to be talking about the absolute value function, the thing we've been looking forward to for quite a while. The absolute value function has the property that whatever value we plug in it, it's going to return a positive value, right? If I have absolute value of -4, I'm going to get a 4. Absolute value of -0.444 is going to return 0.444. So anything that's positive is going to be returned as positive, and anything that's negative is going to be returned as negative. So we can think about this as, we can break it down as a piecewise function. So the absolute value function can be expressed as a piecewise function. So for all values of x which are greater than 0, right, absolute value function of x is simply x. Why? Because they don't need to be changed, right? If you think about it, do they? Like if I have 4, it's going to be the exact same as x, right? It's going to be 4. So ABS of 4 is 4. But at x equals 0, we know that the absolute value of 0 is going to be 0. There's no sign associated at this point, right? Though it won't really matter for x equals 0. What happens for x is less than 0? That's the third part of this piecewise function. Well, as it turns out, this has to be negative x. Why? Because think about it for a second. If you have a negative 4 over here, what would be the function? What would be something multiplied by a function that would give us 4? What do we need to multiply -4 with in an attempt to get 4? It's -4, right? So what I'm saying is, अगर मैंने -4 plug in किया, I need to multiply it by -1 in an attempt to get 4. So that's what this is doing. So the absolute value function for x is less than 0 for all negative values of x is going to give me -x. तो positive हो जाएगा, right? That is the absolute value function, and this is pretty much the definition for it. And so if we were to define continuity for the absolute value function, we would do so in many different forms, but we're going to use the rules that we have. The first rule suggested that f of a exists, right? Let's just write the reference limit down. Limit as x approaches a for f of x equals L, right? That's the reference limit we're going to use. F of a exists, and then we know that limit as x approaches a for f of x exists as well. And the third condition says that limit as x approaches a for f of x has to be equal to the function value f of a in this case. So let's try and doing that. We're going to try to define continuity over here. So let's do the first part, f of a. We're trying to define continuity at a, which is 0 in this case. So does f of 0 exist? Well, if we plug in a 0 over here, we get a 0. We go over here, right? We know that when x is equal to 0, the absolute value gives us 0. So f of 0 exists, right? And its value is equal to 0. Let's talk about the second rule. Limit as x approaches 0 for the absolute value of x. What is that? Basically, does that exist? The first question. And if it exists, what is its value? Let's try to determine that. Now, the problem over here is that since it's a piecewise function, we're going to have to break down the regular limit into the left-handed limit and the right-handed limit. We talked about this a few videos ago, right? And in an attempt to break the regular limit down into two different parts, we're going to re-express it, right? So limit as x approaches 0 from the positive side for absolute value of x. That part, we have to calculate that. And let's just make that negative, you know, because of symmetry, because this part's going to be over here. And limit as x approaches 0 from the positive hand side gives me 1. So as it turns out, when I'm approaching 0 from the left hand side, we could just look over here, right? When I'm approaching it from the left hand side, the function that's going to be used is -x, which means absolute value of x is going to be replaced with that function -x, because that's the function I'm going to be using in this particular case, because I'm approaching it from the left hand side, right? And x is never exactly equal to 0. It's going to be very, very, very close to 0 from the left hand side. So all we're going to do over here is replace absolute value of x with a -x. And since we know it's approaching 0 from the left hand side, what's going to be the limit? Well, for this particular case, let's draw a tiny graph to represent the absolute value function, which is something we should have began with, but no harm. So on all values left to 0, we have the minus x function. So we know y equals minus x looks like that. At x equals 0, that's for x is less than 0, right? For x equals 0, we have 0. And this for x is greater than 0, we have y equals x. So that's what the absolute value function looks like. That's known as the absolute value function, right? So if you approach the limit from the left hand side, we use y equals minus x. And if we use y equals minus x, right, we're simply going to have to plug in a 0 over here because we're approaching that particular point. And it's okay because it's a continuous function. At least this part is. It's going to give me a minus 0, and that's a 0, right? That's the left-handed limit. Let's evaluate the right-handed limit. So the right-handed limit would be re-expressed as the function that's representing x is greater than 0, right? X is greater than 0, and that turns out to be y equals x. So absolute value of x is going to be replaced with x over here, and we will simply plug in a 0 because it's a continuous function, and that turns out to be 0, and the limit is 0 at this point. Now the amazing thing that's happened over here is that the left hand limit is equal to the right hand limit. So 0 is basically equal to 0, which suggests that the regular limit exists. So second condition is true, and the limit is basically 0. Now what's the third condition? The third condition basically suggests that we're talking about the first and the second one, right? We know that the first condition is true. We know that the function value at 0 is true. So what's the third condition? The third condition asks me whether the first is equal to the second. Is it? Well, as it turns out, f of 0 is turning out to be equal to the limit, which means at x equals 0, absolute value of x, ka graph or ka function, is continuous. And what I want you guys to understand in addition to this is that whenever you have the second condition, right, the idea that limit of f of x being like existing, right, this particular part of here, there is a very good chance that every time you do this, you have to divide it into the left hand limit and the right hand limit. So keep that in your mind, right? So whenever you're doing the second condition, you're going to have to check that for the regular limit to exist, it has to be broken down into the left and the right handed limit. And if these two are equal to each other, then only then does the regular limit exist. So that's pretty much it for this video. Thank you for watching. I'll see you guys in the next section.